Rebuilding a vintage open steam launch, Part 14, making a large ceramic gas burner. This is a small ceramic burner, and this burner was made by Mike Abbott of Max Steam, for use in one of the centre flue boilers that he used to make. The burner I need to make is not for a centre flue boiler, so it needs to be larger. The holes in the inlet tube are for what's called the primary air. So I did a quick drawing of the tube layout. This is just on the workbench, as I couldn't find a convenient piece of paper. What I'm going to do is make a sufficiently large ceramic burner to provide enough heat to heat this 5-inch diameter boiler. And what I'm going to use to support the ceramic element is a smoke box door ring from a 5-inch gauge box-hill steam locomotive. I bought 3 fittings from a company called Clevedon Steam. One is a gas valve that fits on top of the gas canister. The other one is an emergency gas cut-off valve, which allows the radio control system to turn off the gas in case of emergency, and the other part is a whistle valve. The gas valve simply screws onto the top of the canister, and that way you can shut off the gas or open the gas fully or anywhere in between. A pipe from this gas tap connects to another gas tap which is radio controlled. If the boiler ever runs low on water, you can turn off the gas remotely. And the third part that I bought from Clevedon Steam is what they call a whistle valve. I'm going to try it initially as a regulator. I'm going to change the union for a 5/32 union. This one is a 1/8 union. I'll give it a quick test, I think, and see how it performs as a regulator valve. When I connect the valve to a compressed air supply, it seems to be fine, and when I connect it to the engine, it also seems to be fine. I will try it because it's much smaller than a slide valve, and there isn't much room in this boat around the engine to put a large slide valve. And this whistle valve seems to work fine as a regulator. This shell for a gas burner I made some time ago and I never completed it, and it's ideal for this size of boiler. And what I'm doing at the moment is bashing it with a hammer on the bench, as you can clearly see. I'm not doing this for fun, and it's certainly not a thing I've got about abusing gas burners. I have to sort of close the copper in a little bit because the ring from the smoke box is just slightly too small to fit in this burner. Yesterday I went up to Blackgates Engineering to get a smaller piece of copper tubing, but they were closed because it's Christmas. I think that Blackgates are open today, but I wanted to do this yesterday. So now I know that the smoke box door ring fits. I'm going to put it in the lathe and machine the inner part of it, followed by the step. This step is going to support the ceramic burner material, and as I'm currently inside turning, I'm using a boring tool for this. I'm machining this smoke box ring on the larger of my two lathes, which is a Smart & Brown model 1024. It's a great old machine. It's a tool room lathe with a very wide bed, and it's fitted with a 4-jaw self-centering chuck, which really grips the work. When I first bought this chuck, I was a little bit sceptical. It was not very expensive, and I think it was made in Eastern Europe, but having said that, it really is good. It's very accurate, and it really firmly holds things in place. To finish the initial machining of the smokebox ring, I simply wind the tool out towards me, which cleans off the front face. I did not have enough ceramic material to do it in one go. I can do it by chopping it in half, as you'll see in a moment, but I'm going to ask anybody who knows where I can get this exact type of ceramic material from, please let me know. I bought this piece from Mike Abbott, but Mike Abbott has ceased trading as Max Steam, so I don't have a source of supply for it. I can get other types of ceramic material, but this is the stuff that I need. The flat ceramic does tend to burn out. I managed to get 2 semicircular pieces from the piece that I had, so at least I'll be able to test it and see whether it needs an internal baffle. As the gas and air mixture enters the burner, what you really need is for it to burn evenly over the surface of the ceramic. But sometimes you will get localized hotspots, and for that it will need a baffle. More about that later. This clip shows the burner after I drilled 4 holes around the perimeter. I'm going to thread these holes and then use some 8BA countersunk bolts to hold the ring in place that supports the ceramic. It feels fairly tight, surprisingly, but it soon wouldn't be if I put any heat near it. So now I have a very beautiful gunmetal ring that fits inside my beaten piece of copper, which is the main body of the burner. This is easy flow flux powder, and here's some I prepared earlier. I always keep a pot of it pre-mixed, and then I put the lid on and it stops the water evaporating. So I'm spreading out the flux inside the burner before I put the ring in place. And now I'm securing the ring to the copper with some 8BA stainless steel countersunk bolts. And once these 4 bolts are in position, I use my soft hammer to just tap all the way around the edge to close the gap as much as possible. As you will see in a moment when I silver solder this assembly, the silver solder will gap fill to a certain extent. But owing to the cost of silver solder, I would rather close the gaps where possible. So it's time to silver solder it now. And the first thing I'm going to do is remove my general purpose nozzle that I use for pipe work and fit a sensible, larger one. I need more heat for this. I couldn't get this hot enough with that small nozzle, but I can with this when I turn the gas pressure up. In no time at all, this gas burner gets the part very hot. I don't want to get it too hot and get it bright red so that it melts, nor do I want to get it too hot so that the existing silver solder on the base melts. So I'm trying to concentrate the heat around the area of the ring, pardon the expression. And before this embryo of a gas burner reaches the critical temperature to melt the silver solder, what I'm going to do is I'm going to put a little bit of silver solder around the edge. Now this is wrong. Please do not follow this example. It's only for the purposes of the video. It's nearly hot enough, and it's hot enough to melt this piece of silver solder. Just watch. Now it's melted and it's stuck to the rim. Again, pardon the expression. But it's not going anywhere yet until the work gets hotter, and then you will see it disappears as it flashes into the gap in the joint. And you don't need to use a lot of silver solder because do bear in mind it's very expensive stuff. I think this used a piece that was maybe 9 inches long. Obviously I couldn't get the last couple of inches of it because it was burning my fingers. And this part of the clip shows me feeding in some more silver solder. Here's the rod coming in from the left, and now that the part is hot enough, you can see the silver solder immediately flashes around the joint. I'm really using more than I need just for the purpose of the video. And in a couple of places the copper has actually opened up slightly. But it's looking like the silver solder is running down into the gap anyway. It's not a good idea ever to use a hammer and try and tap the copper back into position while silver soldering, because hot silver solder splattering onto yourself, whether it's onto your skin or your clothing, is not the smartest thing to do really. I really am using far too much silver solder, but again it's for the purposes of the video. And if I let one of the parts go cold, you can see that it starts to pool on top of the work instead of going round the edge by capillary action. By now the silver solder rod is quite hot, and as I move my hand closer to the flame, it's far too hot. I could of course hold it in a pair of pliers, but that would spoil the fun. This is the only excitement I get these days. Oh, go on then, I'll make an exception to the rule. I'm now holding the last piece of silver solder in this very ancient pair of pliers. And now I'm filling a gap. I really have used miles too much silver solder in this, but you get the idea. I'm closing the gap with the pliers. This is permissible but not recommended. Just before this excessive silver soldering extravaganza reaches its inevitable conclusion, I would like to thank the viewer who wrote in warning me about the potential danger of playing with a piece of pipe on the engine that may be lagged in asbestos. The material in question I don't think was asbestos because it didn't smell like asbestos when I sniffed it, and it didn't taste like asbestos. But thanks for the tip anyway. What I'm doing at the moment is cleaning up the top surface of the burner on my linisher or belt sander, after which I took the part over to my lathe, put it back in the forge-jaw self-centering chuck, and took a nice clean facing cut across the front of it. And the final thing to do is to remove the cover from my acid bath and dip the component into the acid and leave it there for about 24 hours. This should clean off all the flux residue. That's it for now. Thanks for watching, and I hope you found it useful.